Alright, so now we've seen how to selectively write, read, and forget. And so now we're ready to tackle two very famous algorithms, Lsdm and GRU. Lsdm is long short-term memory, and GRU is gated recurrent unit. Okay? So, we will also do a coding exercise on this one, and we'll take the IMDb database, the Internet Movie Review database. And we've looked at IMDb. We actually introduced it when we discussed about naive Bayes. So when doing this, we can compare with the results that we achieved in shallow learning. And what are some of the ideas here in terms of write, read, forget selectively? Well, first of all, ideally we could forget about all these little high frequency words like the, and, or, if, and so on. Also, in terms of selectively read, what we want to read into the memory is words that are really given the sentiment. Sentiment bearing words like amazing, bad, excellent, good, and so on. So these words we want to selectively read. And then at the same time we also want to selectively write new information in the current state. Alright, so very simple here, simple diagram. We have a review of a movie coming in, and that review is processed, and then in the end the network will decide if this is a positive or a negative review. Alright, so let's now derive the formulas for Lstm. There's many variants of the formulas, there's like 10 to 15, and we're going to discuss just one variant. So we're given a certain state, st-1 here, and then we know that a new word is coming in. If you're actually processing a text, you're going to multiply st-1 with w, you're going to multiply xt with u, and then you're going to add them up. And then you're going to add a bias, and you take the sigmoid. And this is exactly what this diagram says. So now what we want to do is, we see that here we have the whole t-1 state in that formula of st. But we don't want to do that. We want to selectively use some information from that state st-1. And how are we going to do it? Well, if this is st-1, we're going to call this one ot-1 and this one ht-1. So that's basically what is going here, what the output is going to be h instead of s. And h is only a fraction of s, because this is organized by this function here. This we call the output gate, or the write gate. And the elements of that gate will be between 0 and 1. Okay? So you will see a sigmoid appear here. Why between 0 and 1? But that because only then, if this is 0.1, this is 0.4, and so on, we're going to pairwise multiply these. And then you're certain to have numbers between 0 and 1 in your ht-1, and it's going to be only a fraction of st-1. Now the question is, how are we going to calculate this ot-1? Well, the answer is simple. We're going to learn this. And learn, that means that we're going to parameterize ot-1 and learn the parameters. So it's not so difficult. ot-1 depends on the previous state, that's ht-2, and I multiply this with w. I call this w0 here. And then I'm going to add u0 times x at t-1. current state, plus I add a bias B0. And are we done? No, we're not done, because I said that OT minus 1 needs to return values between 0 and 1. So we're gonna add the sigmoid here. Yeah? Remember a few lessons ago I told you that the sigmoid is dead, but this was a mistake. Yeah? Sigmoid is far from dead, and it is used, for example, in Lstm. Now we have here 3 new parameters. Yeah? And these parameters give us a bit more control on what information from ST1 to write eventually in the HT minus 1. And then we have that HT minus 1 equals ST minus 1, and then a pairwise multiplication OT minus 1. Yeah, this is our equation. Alright, this for selective write. Alright, let's now go to selective read. Basically, we're going to have a new input xt, and we don't want to read all of xt. Yeah? For example, we don't want to read in stop words like the and are and so on. So here, if we multiply w with ht minus 1 and we add it to u times xt, then we get what we call a temporary state, s tilde t minus, no sorry, s tilde t. Yeah? So that is a intermediate state. That is still not our end state here, which is s of t, state t. Here the same thing. So your s tilde at time t equals, we have w h t minus 1, yeah, and u times xt plus b bias, yeah, and we have a sigmoid here. Alright, so s tilde t is gonna have values between 0 and 1. Now we're gonna define an input gate at time t, and the input gate, so it is input gate or read gate. Yeah, and it is gonna be equal to, yeah, we're gonna have wi ht minus 1 plus ui xt plus bi. Yeah, and again we take the sigmoid here because we want it to be between 0 and 1. Yeah. So, and here again we do pairwise multiplication. So basically in our case is we take s tilde t times it. Yeah, this allows us to selectively take a portion of the new input. Alright, so here again, these are parameters that I introduce and that will need to be learned. Alright, so now let's see how we deal with the selective forget. So here, basically what we have is pairwise multiplication. Yeah. And now the question is, how do we go from this to ST? Yeah. Well, it's not so difficult. Basically what we're gonna do is we're gonna take the previous state, st minus 1, and we're gonna multiply it with a forget gate. This is a forget gate. Forget gate. So here we're gonna do the same, and these two we're gonna add up. Now the question is, why do we use st minus 1 and not ht minus 1? Well, we want the write, the selective write, the selective read, and the selective forget to be 3 separate functions. Yeah? And this then how we do it. So if our st now is equal to st tilde pairwise with it, so this is what we read in selectively, and we're gonna add this to what we forgot in this st minus 1 state. So st minus 1 times ft. Yeah, so this is our final result here for our state ft. And of course we have ft, yeah, ft equals, again, a sigmoid of w forget st minus 1 plus u forget xt plus b forget. Alright? So, and here again we have our parameters that we're going to use in our model. Alright, so this is just a summary of the Lstm. You have selective write, selective read, selective forget, and then here again selective write. So all of this here happens at time t. Alright? And we have our gates here, so we have derived these formulas, and these are our states. So how do we get to these states? Alright? Now there is another variant which is called GRU, or gated recurrent unit. And here we don't have a forget gate, and we don't have the ht minus 1. So we use st minus 1 directly. Yeah, so here are the gates. You only have an output and input gate and 2 states, s tilde and st. And how do we get st here from the previous state? Basically what we say is that whatever we don't use in order to calculate st tilde and it, we're gonna use from the previous state. So here it you use for the current state, and whatever you have not used, you use from the previous state. So 1 minus it. Alright, so we've gone through recurrent neural nets, LSTMs, GRUs. Now it's time to do some coding.